the T-10 tank. The designers built this 50-ton combat vehicle to stand up to NATO forces. It became the Soviet Union's last heavy tank. In the West, analysts pored over intelligence photos from Soviet military parades. NATO staff officers counted columns of armored vehicles rolling through Red Square, and each time they noted how quickly the numbers seemed to be climbing. Western experts believed the Soviet Union had as many as 8,000 T-10 tanks. Those estimates caused real concern inside NATO leadership. Military specialists saw 50 tons of steel as an effective tool for punching through defensive lines. Strategists expected these machines to deliver the first blow against NATO positions if a Third World War ever began. The story of how this tank appeared, ending the Soviet era of heavy armor, and why Western countries watched it so closely has its own historical roots. As the Cold War gathered momentum, the Soviet Union needed new equipment that could outperform the models left over from the Second World War. Wartime tanks were becoming technically outdated, while potential opponents were building up their own armored strength. The main armored directorate wanted a modern, powerful vehicle that was also simple and practical to manufacture, something big factories could push into mass production quickly. By late 1948, the military took a hard look at the situation. The IS-7 heavy tank, weighing almost 70 tons, turned out to be too bulky for the road network and far too complicated to build. Even though it offered impressive protection and firepower, the Army needed something more universal, and something that could be produced in large numbers. With that in mind, the leadership tasked the design bureau at the Chelyabinsk-Kirov plant with creating a tank whose weight would not exceed 50 tons. The engineers decided to use components and assemblies from the IS-4, borrow the armor protection concept from the IS-3, and apply earlier work from the IS-7 project. They labeled the new vehicle Object 730 and gave it the index IS-5. But the supervising agency appointed not a Chelyabinsk specialist as the project lead, but Joseph Yakovich Kotin, the chief designer of the Leningrad Kirov plant. That decision had a clear practical purpose. The organizers wanted to set up joint work between two major enterprises and ensure the tank could later be produced at both sites. The Chelyabinsk plant had huge production capacity, while the Leningrad plant had an experienced engineering staff. To reinforce the Chelyabinsk team, the ministry transferred more than 40 specialists to the city from the All-Union Scientific Research Institute, based on the Leningrad branch of Experimental Plant No. 100. Development began immediately and moved at a fast pace. The engineers relied on earlier work tied to the IS-3, IS-4, and IS-7, so by April of 1949 they had a preliminary design ready for the new machine. A month later, in May, the team presented a full-scale wooden mock-up to a joint commission. It included representatives from the Ministry of Transport Machine Building and the Armed Forces. The military examined the model, checked crew layout inside, and judged how convenient it would be to work with the mechanisms. The commission raised only a minimal number of comments, and by June of that same year, the factories received most of the working drawings. At the same time, specialists in Leningrad were refining individual assemblies. They ran bench tests and mobility trials on key parts of the future tank. The plan called for 3 vehicles to be assembled by August for state trials, and then 10 more tanks by September for troop testing. But the manufacturing plants ran into problems that threw those original plans off track. Workers managed to assemble the first vehicle only on the 14th of September, and the second one rolled out a few days later. Production kept slipping behind schedule, defects showed up, and a long list of shortcomings surfaced. One of the biggest headaches was the transmission. It proved unreliable and regularly failed during operation. Once word of the missed deadlines reached him, Joseph Stalin issued a new decree on the 15th of October, 1949. It set new deadlines that were much tougher than before. Under the new requirements, engineers had to finish the multi-stage factory and state trials of 5 tanks no later than the 15th of July, 1950, and then, based on those results, run troop trials on 10 more vehicles. Factory testing did start on the updated schedule, but the earlier technical issues still hadn't been solved. From November of 1949 through February of 1950, specialists carried out winter trials on 2 examples of Object 730, vehicles numbered 3111 and 3122. At the same time, in sub-zero conditions, engineers checked how the 700 horsepower V12.5 engines behaved. Test crews took the machines onto snow-covered ranges, forced them through obstacles, and pushed every unit and mechanism to see what would break first. The factory test results were mixed. The transmission, fuel tanks, and armament showed a high level of reliability, but parts of the running gear failed from time to time. Army representatives also complained about the noise level, the uncomfortable crew, layout in a cramped fighting compartment, and the difficulty of field maintenance and repairs. The designers kept making changes, refining mechanisms, and reworking assemblies under very tight time pressure. In February and March of 1950, the Chelyabinsk-Kirov plant assembled 3 more experimental Object 730 vehicles. Testing of this new batch began in April, and they deliberately chose sharply different climates. Near Leningrad, the tanks were evaluated in spring mud, dampness, and cold. In Turkestan, test crews sent the same machines down dusty routes in high heat. The trials continued into mid-May. The commission found a number of flaws, but overall it gave the vehicles a positive assessment. Even so, on several key indicators, the equipment did not pass state trials. Defense Minister Alexander Vasilevsky and Transport Machine Building Minister Yuri Maksaryov drew up and approved a substantial list of required improvements. Factory engineers had to meet those demands before the Army could accept the vehicle into service. At the same time as the official trials, specialists at the Kubinka Proving Ground carried out intensive live fire testing against the tank's hull and turret. They fired on an Object 730 vehicle that already had its running gear, main gun, sighting equipment, and aiming mechanisms installed. The testers used a 122mm D25 gun, an 88mm PAK gun, and a 76mm ZIS-3 gun. The results showed that the new model's hull was stronger than the IS-3's, while their turrets offered roughly the same level of protection. Even before the full test cycle was completed and the identified issues were fully addressed, the manufacturer began building 10 vehicles intended for troop trials. But the plant still couldn't meet even the revised schedule. Workers didn't start assembling that batch until June of 1950, and the finished machines were handed over in early September. The next testing phase ran through October and November of that same year. Despite a number of technical shortcomings, Object 730 generally showed better day-to-day performance than other models then in service, including the IS-2, the IS-3, and the T-3485. Testing continued through 1951. Then from May through June of 1952, the program returned to field trials near Samarkand. 2 control vehicles ran long, multi-kilometer routes in heavy dust and extreme heat. The armor got so hot that a person couldn't touch it with bare hands. After the heat testing, specialists moved one tank into a special refrigerated chamber at the proving ground. That made it possible to check how the engine preheating system worked in severe moroz conditions. Once again, the vehicles failed to clear every stage of the trials because engineers uncovered new weak points. Even so, the Commission recommended producing a control batch of 50 Object 730 tanks, fixing every defect on that batch, and only then deciding whether the Soviet Army should adopt the vehicle. By the fall of 1953, so many changes had been introduced that the tank's index in the paperwork shifted several times, from IS-5 to IS-8, then to IS-9, and later to IS-10. On the 28th of November, 1953, The Council of Ministers issued a decree under which the Soviet Army adopted Object 730 under the designation T-10. Joseph Stalin had died in March of that same year, so the new machine never received his name. His death slowed the adoption process, and in the end this heavy armored vehicle went into service without an honorary name at all. The original plan called for the Chelyabinsk plant to turn out 6 tanks per day, which would have meant 1,830 vehicles a year. But production ran into major obstacles. By the end of 1954, the plant had assembled only 20 serial T-10 tanks. There were objective reasons for that. The enterprise was working on more than 10 experimental vehicles of different types at the same time. The T-10 constantly fell short of needed components, suppliers shipped defective parts, and workers were tied up on other projects. Despite all those difficulties, in 1955 the Chelyabinsk plant improved the situation, met the plan, and delivered 90 T-10 tanks to the customer. Overall, from 1954 through 1956, manufacturers produced 190 serial vehicles, not counting 15 earlier experimental Object 730 prototypes. Gradually, production picked up, and the Soviet Army began receiving these heavy tanks. The T-10 used a classic layout that engineers had already proven in earlier armed conflicts. The control compartment sat up front, the fighting compartment was placed in the middle of the hull, and the engine and transmission occupied the rear. Workers welded the hull from rolled armor plates, and some roof and rear sections were bolted on, so mechanics could service components and assemblies more easily. The front of the hull consisted of a lower sloped plate and 2 upper sloped plates, each 120 millimeters thick. The designers set them at rational angles so the armor would better deflect incoming rounds. The sides were formed by a welded upper straight 80 millimeter plate and a lower bent plate of the same thickness. The rear of the hull was built up from several separate elements. Welding securely tied the upper 80 millimeter plates to the side armor. A lower 60 millimeter plate connected the sides and the bottom, while an upper 50 millimeter plate was hinged. That gave straightforward access to transmission components during repairs. The T-10 hull had a flat bottom 16 millimeters thick. The cast turret armor, made from medium hardness MZL1 steel, used varying angles of slope. Thickness reached roughly 250 to 275 millimeters on the front, about 102 to 157 millimeters along the sides, and about 90 millimeters at the rear. The turret roof and the engine compartment bulkhead included ventilators. They effectively cleared the fighting compartment of propellant gases produced by the main gun. The turret had 2 crew hatches, and one of them was fitted with an anti-aircraft mount, carrying a DSKT machine gun. The tank's main armament was a 122 millimeter D-25TG separate loading gun, paired with a DSKT machine gun. Its direct fire range was 1,000 meters, its aimed range reached 5,000 meters, and the maximum permitted firing range was 15,000 meters. The onboard ammunition supply included 30 rounds for the gun and 1,000 machine gun cartridges. Special stowage racks along the turret walls, the floor, and the fighting compartment walls held the shells and propellant charges securely. To boost the rate of fire and make the loader's job easier, the gun was fitted with a special electromechanical rammer. With that system, the tank could fire about 3 to 4 rounds per minute. Traditional manual loading usually meant only 2 to 3 rounds per minute, which didn't meet the demands of the kind of intense combat planners expected at the time. The vehicle also had powered aiming drives. Both the gun elevation mechanism and the turret traverse mechanism used electric motors, but they also included backup hand controls. If the electrical system failed, the crew could still keep the gun in action. The DSK anti-aircraft machine gun was mounted on the loader's hatch. It provided full Krugovaya traverse on the horizontal plane and could elevate up to 85 degrees. For engaging aerial targets, the gunner used a K-10 collimator sight. And beyond the main gun rounds and machine gun ammunition, The fighting compartment also carried stowage for 20 F1 grenades, 26mm cartridges for a signal flare pistol, and 2 AK-47 rifles with a combined load of 300 rounds. At the rear of the hull, metal straps secured BD-5 smoke canisters to special brackets so the tank could be screened on the battlefield. The driver mechanic could ignite and release them by pressing the appropriate buttons on the instrument panel. For power, the T-10 used a 700 horsepower, 12-cylinder V12.5 supercharged engine with a liquid ejection cooling system, an arrangement engineers had carried over from the IS-7. The vehicle also had a dedicated fire suppression system designed to put out fires in the engine and transmission compartment. Fuel was carried in 3 internal tanks with a total capacity of 460 liters, plus 2 external tanks of 150 liters each. Those external tanks were tied into the main fuel system, which meant the crew could draw on the entire fuel supply without extra transfers or refueling steps. That volume gave the tank a road range of about 200 kilometers on paved routes and roughly 150 kilometers on dirt roads. The transmission included a single-flow gear and steering mechanism, along with 2 final drives. Those sat between the gearbox and the drive sprockets and helped take weight loads off the drive wheels. The running gear on each side included 7 road wheels and 3 return rollers, plus an idler and a drive wheel. The cast metal road wheels, about 550 millimeters in diameter, used internal cushioning. The idler wheels could pull-and-stew replace road wheels if needed, and they worked with crank and screw track tension mechanisms. Engineers fitted the drive wheels with removable toothed rings for the pin-type track engagement. That made maintenance much easier, and it simplified replacement once parts wore down. Each track consisted of 88 cast links, 700 millimeters wide, joined by pins and eyelets. To help the vehicle get through deep mud, swampy ground, or heavy snow, the crew could install special rasciutelli on the track links. A full set of 174 of these pieces weighed 1,650 kilograms. Modernization work actually began as early as 1951, before the tank was officially adopted. The designers understood the weak points of the layout and immediately started looking for technical fixes. In total, the manufacturer carried out 3 major modernization programs, which led to the T-10A, T-10B, and T-10M variants. Across every stage of that upgrade path, the main priority was to fit the gun with the stabilizer in the vertical plane and to introduce a fire control system. The basic T-10 could only make an aimed shot after coming to a complete stop, at least for a few minutes. The crew could fire effectively on the move only over perfectly flat ground, and even then the hit probability did not exceed about 1.2%. With an ammunition load of only 30 rounds, that kind of accuracy made firing on the move almost pointless. In February of 1956, researchers completed trials of Object 267 SP1, the future T-10A, and the results looked promising. With the stabilizer installed, hit probability while moving jumped to roughly 55 to 60%, a major technological step forward. Engineers equipped the tank with the Uragan fire control system and an updated 122mm D-25TS gun. It received a ramming mechanism for both the projectile and the cartridge case, along with a device that cleared propellant gases from the bore after firing. On top of that, the designers introduced a number of other technical changes. They increased fuel capacity by 180 liters, replaced the starter and generator, and added a gyro semi-compass for more accurate navigation. Under a government decree dated the 17th of May, 1956, the military accepted the vehicle into service. It received the official designation T-10A and the factory index Object 731. The manufacturer moved quickly into production. By the end of that same year, workers assembled 30 vehicles, and the following year they built another 20. After that, the plant stopped producing the T-10A, shifting toward a more advanced modification. The next version, the T-10B, also known as Object 267 SP2, differed mainly in its GROM fire control system. This setup significantly improved firing effectiveness on the move, because it stabilized the line of sight in the vertical plane and kept the turret and gun steady in the horizontal plane. Along with the GROM system, the designers fitted the B model with a more powerful generator to supply the extra equipment. In every other respect, this version essentially repeated the T-10A. But the new system turned out to be unfinished, and crews regularly reported problems. It could shut itself off without warning, malfunction during aiming, or fail entirely at the worst possible moment. Under another government decree, dated the 11th of February 1957, the Army adopted Object 267 SP2. Under the official designation T-10B, serial production began at the plant, where it received the index Object 733. By the end of 1957, according to different sources, manufacturers produced somewhere between 110 and 130 T-10B tanks. Soon after, the responsible ministry halted production completely, because a fully modernized version, the T-10M, was already ready. Based on the standard T-10, designers also created a commander's tank, the T-10BK. It carried an additional radio set and a more powerful generator to run it. The first heavy T-10 tanks reached frontline units in 1955 and 1956. They were issued to the 7th Separate Cadre Tank Division and to a division of the 5th Army. Before long, the military leadership decided to form specialized formations, heavy tank divisions. On paper, each division was supposed to have 200 T-10 heavy tanks. Over 1957 and 1958, Command created 8 such units. Rather than raising brand new formations, the military reorganized existing ones, changing their numbering and adding the word heavy to the title. And alongside the new T-10s, these units continued to operate older machines as well, including the IS-3 and the IS-2, which created real headaches for maintenance and spare parts supply. Western analysts at the time seriously overestimated how many of these tanks were being produced, assuming the Soviets had more than 8,000 of them. Those NATO estimates were far above the real production numbers. Even today, historical sources don't fully agree on the exact total, with figures ranging anywhere from about 1,500 to 8,000 vehicles built. But the most credible research suggests that by 1966, the Army had roughly 1,500 T-10 tanks in service, more precisely about 1,390 machines. That count included every modification: the T-10, T-10A, T-10B, and T-10M. Most of that fleet consisted of 1,189 examples of the most advanced version at the time, the T-10M. And because the different versions had major design differences, operating them side by side created serious technical and logistics problems. Some vehicles used a planetary transmission with hydraulic control, while others had a purely mechanical one. Fuel tank capacities also differed, as did the aiming, stabilization, and control systems. When the leadership of the Armored Directorate discussed maintenance and long-term service, they proposed modernizing the tanks to standardize the entire fleet. But the military leadership rejected the idea and never carried it out. Command decided it was simply easier to replace older vehicles with newer ones over time than to spend major resources rebuilding tanks that were already in service. Becoming a T-10 commander was not easy. Only one school trained command personnel for heavy tank units, the Ulyanovsk Tank School. In the cadet battalion, only one company out of 3 trained specialists for the T-10, which meant there was a constant shortage of qualified officers. The school graduated its last officers in that track in the early 1970s, after which the need for that kind of specialized training disappeared. The first units to receive the new heavy tanks were formations stationed in Germany. Under the tense conditions of the Cold War, these T-10 crews operated with a reduced team, 3 people instead of the 4 authorized by the official tables. There was no dedicated loader. Instead, once the tank reached its assigned point, the driver mechanic took over loading duties. The logic was simple. After taking up a firing position near the border, the tactics did not call for further maneuver. The crews were expected either to wait for the main forces to arrive or to hold their positions to the end, beating back an enemy advance. Each battalion tank crew had a clearly assigned sector of fire and pre-prepared fire cards with ranging points already dialed in. During exercises, T-10 drivers and commanders traveled by car along the expected routes the tanks would use to move up to firing lines. At the same time, the tankers wore uniforms without insignia. The idea was to prevent foreign intelligence from identifying ranks and specific unit affiliations if the soldiers were intercepted or observed. The military kept a tight veil of secrecy around the T-10. Relevant agencies maintained the classified status of the tank's operating manual all the way until 1974, even though by then the vehicle was already beginning to look outdated. These tanks did not take part in large-scale combat. The Army avoided deploying them precisely because secrecy requirements were so strict. The Soviet Union never exported the T-10 to allies abroad, so it never appeared in their wars either. The public saw these machines only once, during Operation Danube, when Soviet troops entered Czechoslovakia in August of 1968. Heavy tanks rolled through the streets of Prague, projecting Soviet military power and signaling the political leadership's intent to halt the events of the Prague Spring. Separate border guard tank battalions remained in service until the end of 1976. After that, command transferred the T-10s to training tank regiments within the group of Soviet forces in Germany, and logistics units gradually shipped them back to the Soviet Union. Military command placed the main storage bases for these heavy tanks at the home stations of 2 divisions, the 5th in Belarus and the 42nd in Ukraine. There, specialists kept the vehicles preserved in long-term storage as a reserve for a large-scale war that, in the end, never came. From the mid-1980s, the Army began gradually writing off the T-10 series, sending their hulls to industrial plants to be melted down. The era of heavy armored vehicles was reaching its historical end. Their place in the force structure was taken by main battle tanks, which combined strong firepower, reliable protection, and mobility much more effectively. Russia finally removed T-10 tanks of all existing variants from service by a presidential decree dated the 23rd of September 1997. That official document drew a line under their story, ending more than 40 years of military service.